Hi everyone, in this video we're going over transformations, specifically translations, which is 3A. But just quickly, transformations just means your graph or your basic graph, let's say, well, it doesn't have to be the basic one, but let's say we've got a parabola, y equals x squared. It can be dilated, so it can become narrower or wider. It can be reflected, so it can become a negative parabola and it turns upside down, or translation, so it can move left, right, up or down. In this video, we're going to focus on just translation. So you can have horizontal translation, so moving along the x-axis. Now, try not to use the phrase moving to the left or to the right. You do need to say what I've got written here, and let me just highlight it. All right, moving, oops, it's not very straight. Moving h units, so whatever it is, so if it was 2 units in the positive direction along the x-axis. If you're moving to the left, you say in the negative direction. So just that mapping there, your x value, we're just adding whatever h is. And then for, if we're moving in the negative direction, we're just subtracting h. Now this is only for mapping points. All right, so just make sure you don't get mixed up when you just look at a function and decide what transformations they are. So we'll talk about that a bit later. Vertical translation is going up or down, but we do say that we're in the positive direction of the y-axis if we're going up, or negative direction if we're going down. So your y-coordinate is either shifting up or shifting down. Now you can have a combination. So you can see there's all the different possibilities you can have. All right, so x can go up. X can go to the left or in the negative direction of the x-axis, and y can also go, y can go down, whatever. All right. I'm just going to quickly move through this because I'm trying to get this done before the bell goes for recess. Okay, so if I had a point, let's say I had the point 3, 5. So that point on a Cartesian plane, let me just quickly draw it here. So if we had number 3 and there's 5, and here's the point here. All right, so there's our point. Now that could be a point on its own, or it could be on a graph, and it doesn't matter what graph it is. All right, so let's say this point has gone 4 units in the positive direction of the x-axis. All right, I'm just going to do a bit of shorthand because I'm running out of time. Negative direction of the y-axis. So that means it's gone to the right and it's gone down. So the point 3, 5, which you can see here in yellow, which I've just now put in blue, it's gone to the right 4, and then it's gone down 3 to end up here. So your coordinates for that, if we started at x equals 3 and then we went across 4, we're going to end up at 7. And if we started at y equals 5 and we went down 3, we're going to end up at 2. So effectively what we've done is 3 plus 4, 5 minus 2. So your new point is going to be 5 minus 3, which is 2. 7, 2. All right. Now, just looking at sketching, so these diagrams here, it's just looking at a parabola and it's gone left, right, up or down, and you can see how the points are mapped here. And then your resulting equation. So we're going to have a look at why we've got a negative there in a second, but basically we've got a parabola, basic parabola, which is blue, and it's either gone to the right, as in the first example, to the left in the second example, and then we've got up and down. So you can see how your points changed as well. So good diagram to see what is happening, and it's a bit harder to see. I might just highlight this in a different color. Just the point moving. All right, and we'll see it over here as well, how the point has shifted across or up or down. All right, so let's have a look at an example. So I'm going to look at a basic hyperbola. So what y equals 1 over x, and I'll just sketch it over here. Now, whenever you have to sketch, or even if you don't have to sketch, it's a good idea to picture what that looks like. So a hyperbola goes like this, and it does have asymptotes because the denominator cannot equal 0. So we've got 1 over x. I'll just go back over here. 1 over x, so that x cannot equal 0, otherwise it's undefined. So that's why you get your asymptotes. So we're looking at our domain and range for this original function. All right, so for your possible x values, we're starting at 0. Actually, no, we're not. What am I doing? We can have any real value except for the asymptote, so except for 0. So I was only going to look at the positive section of the negative part of the graph as well. And then your range is the same, so any real value excluding 0. All right, so there's our basic hyperbola. Now what we're going to do is go through just 2 transformations. We're going to go 3 units. I don't like it when it does that. Sorry. I don't know why it does that. Start again. All right, 3 units in the positive direction of the x-axis. Now I'm just writing shorthand. You should write the whole thing, and 2 units. And then, oh gosh. I think I accidentally press a button when I do that. 2 units in the negative direction of the y-axis. So what's happening, our point xy now becomes a new point x dash y dash. So when we undertake that transformation, our x, we're adding 3, and our y, we're subtracting 2. Okay, so we're going to the right 3 and down 2. Now, what I need to do is say, well, my original function is a hyperbola. So, whoops, y equals 1 over x. And I need to put in these points, new points, but I don't put in x plus 3, y minus 2. I have to say, well, my new x value is equal to x plus 3, and my new y value is equal to y minus 2. But in this function here, so I know you can't see my ruler, my pointer, we have x and y. So I'm going to have to substitute in, don't know why I wrote x plus y there, should be x plus 3. We have to substitute in x. So I'm just going to have to rearrange this equation. So I'm going to subtract 3 from both sides. That goes. And I now get x equals x dash minus 3. So in my function, wherever I see x, I need to put in x dash minus 3. And let's just rearrange the y. So we're going to add 2. And my y is going to become y equals y dash plus 2. All right, so let's substitute it into our function now. So instead of having y, so instead of this y, I'm going to write y dash plus 2. And instead of this x, I'm going to write in x dash minus 3. So it's going to be 1 over x dash minus 3. All right, just solving this equation now. I'm not solving, but rearranging. We've got y equals 1 over x minus 3 minus 2. You'll notice I've dropped the dash on the x and the y. That's because our image we don't need to put that in. All right, so that's our new equation, and it's 1 over x has been translated 3 units to the right and 2 units down. Okay, so our asymptotes. So before we had an asymptote at x equals 0 and y equals 0, because our graph has been shifted 3 units in the positive direction along the x-axis, so this vertical asymptote has now gone from x equals 0 to x equals 3. And when you think about it, if I was to substitute 3 into there, it would equal 0, and we can't have that. And my horizontal asymptote has shifted down 2, so it's now at y equals -2. Now my hyperbola, let's just quickly draw it. Now we're not going to do it with any intercepts, axis intercepts today, but you probably should. And they're easy to do. You just let x equals 0, y equals 0, blah, blah, blah. Okay, so there's our new graph. Let's just write the domain and range. All right, so remember on our previous graph, a domain and range, it's any real value excluding where those asymptotes were. So it's the same here. It's any real value excluding the asymptote. So for x, it was at 3. That is a terrible 3. What am I doing? I'm getting my brackets mixed up with my 3. There we go, that's better. And my range is also any real value, but this time it's excluding -2. All right, looking at some practice questions, and we've probably got about less than 10 minutes, so we'll see how many we actually get through. How many questions I've got? Oh, I've got a few over the page. So we're going to have to sketch the graph of each of the following and label asymptotes and x-intercepts and state the domain and range. So when you're doing a question like this, it's asking for you not just to sketch. So we've got to, where can I write this? We've got to sketch, label asymptotes, axes intercepts, domain, and range. So if I had a question like this on an assessment task, I would actually write everything that the question is asking. And then when I'm done, all right, have I sketched it? Yes. Have I put in the asymptotes? Yes. Did I put the axis intercepts in? Oh, no, better go and do that. Did I state the domain and the range? Okay, so you don't want to forget something, because in methods, questions are worth a lot of marks. And if you forget something, it's probably not because you can't do it, you just didn't read the question properly. So it doesn't take long to quickly write those things. All right, and then tick them off as you've done them at the end. Okay, so this time we're looking at functions and looking at the transformations they have. So when I look at an equation like this and I'm thinking about the graph, I say, okay, well, it's a hyperbola because it's 1 over x. So I'm picturing a hyperbola in my head, and the +3 means it's been shifted up 3. The next one is a square root graph. This one's a little bit harder, but the -2 just means it's shifted to the right 2. Okay, so this should be a bit of revision from last year. Then we've got another hyperbola, but this time it's shifted to, so I'm just making sure I got it right, to the left 2. And then we've got a truncus that's shifted down 3. And then we've got some questions over the page. So let's do some graphing, and then we might do a separate video for the other stuff. Okay, so this is a hyperbola that has gone up 3. So when I sketch it, my original hyperbola had asymptotes at x equals 0 and y equals 0, but because this one's been shifted up 3, our horizontal asymptote is now at y equals 3. So I've got to label that. And our vertical asymptote still stays at x equals 0. All right, so I can see this part of my hyperbola does not cross the axis intercepts at all, but my other one does. So I'm going to have to find the x-intercept. We let y equal 0. So obviously you can do this on your calculator, but we're going to do it by hand. So 1 over x equals -3. So x equals negative 1 over 3. So that's going to be, it's a bit hard to see on this graph. Right, so that point there, it's -1/3 0. Right, it doesn't cross the y-axis, and that's a bit wonky at the end there, but it's all good. All right, so let's, oh, we haven't done the domain and range. All right, so your domain, because our asymptote hasn't moved, it's going to be any real value excluding 0. And our range, so our asymptote did shift up, so it's any real value excluding 3. All right, so you can see it there. All right, let's just check our checklist. So we've sketched it, yes, put the asymptotes on, yes, and we've labelled those asymptotes, put the axis intercepts in, yes, and stated the domain and the range. Awesome. All right, let's do this hyperbola down here. So the 1 over x plus 2. So this is a hyperbola again. And what has happened, it's shifted to the left too. All right, so let's draw our asymptotes. So because our asymptote, our vertical asymptote has been shifted across to, and you can always check, because remember that denominator cannot equal 0. So that means x cannot equal -2. All right, so our horizontal asymptote is at y equals 0, and then our vertical is at x equals -2. All right, I can see that we're not going to have axis intercepts down here. So I'm just going to sketch that one. But for the top part, I am going to cross the y-axis. So I'm going to have to find the y-intercept. Let x equal 0. So y is going to equal 1/2. Right, so let's put that here. Not the best at drawing graphs on the screen. All right, so that's 0.5 for our y-intercept. All right, domain and range. All right, so your domain, because your graph is shifted to the left too, it's going to be any real value excluding -2. And our range, because we haven't shifted up or down, it's just staying at any real value excluding 0. All right, I'm going to have to end the video there just because it's nearly recess. And I have to go to recess duty, but I'll do a second video for the remaining questions. All right, bye girls.